This is section 10.3, day 2 notes. Find the specified term for each geometric sequence or sequence with the given characteristics. A sub 6 for 6.06.0006. So here we're dividing by 100 or multiplying by 1 over 100. And we have the first, the second, and the third term. So A sub 4 is 0.000012345 A sub 5 is equal to 0.1234567 and A sub 6 is 12345678910. A sub 2 for A sub 4 is 1 over 81 and R is 1/3. Well, if you go from A sub 2 to A sub 4, you multiply. So to go from A sub 4 to A sub 2, we're going to divide. So A sub 3 would be 1 over 81 divided by 1/3, or 1 over 81 multiplied by 3 over 1. Multiply by the reciprocal. That's 1 over 27. A sub 2 now is 1 over 27 and divided by 1/3, or multiplied by 3 over 1, which is 1/9. A sub 1 for A sub 5 is 486 and R is 3. A sub n is A sub 1 times R to the n minus 1. Now we have A sub 5. That's 486 is equal to A sub 1 times 3 to the 5 minus 1. So 486 is equal to A sub 1 times 3 to the 4th. A sub 1 is equal to 486 divided by 3 to the 4th is 81, and that is 6. So A sub 1 is 6. A sub 7 is, we're finding A sub 7. And A sub 1 is 2 square root of 5, and then we multiply this by 2 square root of 5, negative 2 square root of 5, because negative 2 times 2 is negative 4, and square root of 5 times square root of 5 is 5, so there's where you get the negative 20. So A sub 1 is equal to 2 square root of 5, and R is negative 2 square root of 5. So A sub n is equal to A sub 1 times R to the n minus 1. A sub 7 is equal to 2 square root of 5 times negative 2 square root of 5 to the 6th. So we have 2 square root of 5, and then negative 2 to the 6th would be a positive 64. And then we have 5 really to the 1/2 power, that's square root. So that's really to the 6/2 power, and that's 5 to the 3rd. So we need 2 times 64 times 125. That's 5 to the 3rd. So we get 16,000 times the square root of 5. Find each sum. The first 11 terms of this series right here. Well, A sub 1 is 2/3, and it looks like we're multiplying by 4/5. A sub 1 is 2/3 and R is 4/5. And we need the sum. This is geometric. So S sub 11 is equal to A sub 1 times 1 minus R to the 11th divided by 1 minus R. And we go to the calculator for this one. So we got 2/3 times 1 minus 4/5, notice the use of parentheses, to the 11th. Let's get that answer. And then we'll divide by 1 minus 4/5 is 1/5. So divided by 1/5. Let's see if that's a nice fraction. I don't think it is. Nope. So 3.047. We're finding the sum of these terms here, and we're going from 6 to 13. Now, if you take 13 minus 6, that's 7, but there's one more because we're counting 6. So we need S sub 8 is equal to, here's A sub 1 right there, which is negative 3 times 1 minus 2.4, that's the R, to the 8th over 1 minus 2.4. So negative 3 times 1 minus 2.4 to the 8th, and then divided by 1 minus 2.4. So that's equal to negative 2356.614 rounded. This one is infinite because of the plus dot dot dot. So a sub 1 is 12 and r is 1/4. We're multiplying by 1/4 every time. So the sum is equal to 12 over 1 minus 1/4. It's, where should I write that? The sum is a sub 1 over 1 minus r. Well, we can multiply everything by 4. Everything by 4. We get 48 over 4 minus 1. So 48 thirds, and that is 16. Here we're adding an infinite amount of terms, but we're starting with n equals 2. So a sub 1 is 2 times 1/4 to the 2 minus 1. To get the first term, we plug 2 in for n. That's 2 times 1/4, and that's 1/2. So a sub 1 is 1/2, r is 1/4. So the sum is a sub 1, 1/2, over 1 minus r, which is 1/4. And we'll multiply everything by 8. That's the common denominator with the little denominators. 4 over 8 minus 2. So 4, 6, and that's 2/3. In exercise 1 through 12, write the first 4 terms of each sequence whose general term is given. A sub 1 is, well, negative 1 to the first is negative, so this is going to be negative 1 plus 3, so negative 4. A sub 2, well, negative 1 squared is positive, so this is just 2 plus 3. That's 5. A sub 3, negative 1 to the third is negative 3 plus 3, and that's negative 6. A sub 4 is equal to, well, negative 1 to the fourth is positive, so that's 4 plus 3, and that is 7. The sequences in exercises 13 through 18 are defined using recursion formulas. Write the first 4 terms of each sequence. Well, a sub 1 is 7. A sub 2, we take the previous term and add 5. So that's going to be 12. A sub 3 now is 12 plus 5, and that's 17. And a sub 4 is 17 plus 5, and that is 22. In exercises 23 to 34, write a formula for the general term, the nth term of each arithmetic sequence. Do not use a recursion formula. Then use the formula for a sub n to find a sub 20 in the 20th term of the sequence. So write a formula. A sub n for an arithmetic sequence is a sub 1 plus n minus 1, and then times the common difference, which is 4 here. We have 1 plus 4n minus 4, so a sub n is equal to 4n minus 3. And then we're asked to find the 20th term, which is 4 times 20 minus 3, 80 minus 3, 77. Find the sum of the first 50 terms of the arithmetic sequence. The sum. We want the sum. S sub 50 is equal to 50 over 2 times negative 15 plus the last term. So we need a sub 50. We're missing this last term here, which is a sub 1 plus 50 minus 1, and then the common difference is 6. Looks like we're adding 6 every time. Let's get that value. Negative 15 times 49 times 6. Oh, I need a plus there. Plus. And that's 279. 279. So the missing value, the a sub 50, the last term, is 279. So 50 divided by 2 is 25 times negative 15 plus 279. 6,600. For exercises 45 to 50, write out the first 3 terms in the last term. Then use the formula for the sum of the first n terms of an arithmetic sequence to find the indicated sum. So write out the first 3 terms. Well, 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. Let's write the last term. 100 times 4 is 400. So S sub 100 is equal to 100 over 2 times 4 plus 400. We have 50 times 404. 20,200. Here we start with 10, so 30 minus 2 is 28. 11 times 3. 33 minus 2 is 31. And 12 times 3 is 36 minus 2 is 34. Plus, keep on going. And then 60 minus 2 is 58. So S sub 11. S sub 11 is equal to 11 over 2 times 28 plus 158. So 5.5 is what 11 divided by 2 is, times 28 plus 158. So 1,023. Find the sum of -6 plus -2 plus 2 plus 6 plus keep on going. Looks like we're adding 4 every time. Adding 4. So this is arithmetic. S sub n is equal to n over 2 times -6 plus 114. Well, we don't know what the n is, but we know that a sub n is equal to a sub 1 plus n minus 1 times, we're adding 4 every time. So let's add 6, that's 120, is equal to n minus 1 times 4. 30 is equal to n minus 1, so n is 31. So we have S sub 31 terms. 31 terms. 31 divided by 2 times -6 plus 114. We have 1,674. Find n for 4 plus 12 plus 36 plus 108 if S sub n is 118,096. Find n. S sub n 118,096 is equal to a sub 1 times 1 minus the r is 3. 3 to the n over 1 minus 3. Well, let's take 118,096. Let's multiply by -2. We have -236,192 is equal to 4 times 1 minus 3 to the n. So we're going to divide this by 4. So we have -59,048 is equal to 1 minus 3 to the n. Let's minus 1. So we're going to minus 1 over. So -59,049 is equal to -3 to the n. We'll divide by -1. So we have 3 to the n is equal to 59,049. Well, now let's take either log or natural log. I like taking natural log of both sides. Natural log of 3 to the n is natural log of 59,049. I can bring the n down. We have natural log of 59,049. And now we just need to divide over the natural log of 3. So natural log of 59,049 divided by natural log of 3. 10. So n is equal to 10. Find a sub 1 for which S sub n is -1,092, r is -3, and n is 6. Oh, we're finding a sub 1. Well, we know the sum is -1,092. We have a sub 1 times 1 minus r to the n, which is 6, over 1 minus r. Let's take -1,092. We're going to multiply by 4, because 1 minus -3 is 4. So -4,368 is equal to a sub 1 times 1. Well, let's get this value here. Let's get this value too. We can do 1 minus -3 to the 6th. Oh, I didn't have a parenthesis over here. Should I delete that? There we go. -728. -728. Well, now we just need -4,368 divided by -728. So a sub 1 is 6. Find the sum. Well, a sub 1 is 3, and r is 2/3. Now, in order to have an infinite sum, the r must be less, the absolute value of r must be less than 1. And then the sum is a sub 1, which is 3 over 1 minus r, which is 2/3. So now if we multiply everything by this, the 3 here to get rid of this 3, multiply by 3, we get 9 over 3 minus, when those cancel, we get 2, which is 9. Here, r is equal to 3 halves, which is greater than 1, so there's no sum.